Welcome to Polygons. In this lesson, we will examine different characteristics of polygons, what is a polygon, what isn't a polygon, as well as work on naming polygons. So let's first look at what exactly is a polygon. If you look over here, you'll see here's some examples of polygons. Here's some examples of not polygons. What do you notice to be the difference between the two? Well, a polygon has to be a closed figure. It can't be open. There must be connecting line segments. Notice in this one, these line segments do not connect to anything. And each segment intersects exactly two others. So we can't have one line that intersects three different lines. Each line segment is called a side of a polygon. Each endpoint where the sides meet is called a vertex of the polygon. So that refers to the points here, 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 and here, for example. Also, you should know a polygon is classified by the number of sides it has. Let's name some polygons. You should write these in your notes so you have them in case you need them. 3 sides, what is that? That's a triangle. 4 sides. We call that a quadrilateral. There are different types of quadrilaterals. 5 sides is a pentagon. 6 sides is a hexagon. What about 7? That's a heptagon. 8 you're familiar with, that's an octagon. 9 is a nonagon. 10 is a decagon. 11 is an undecagon. And 12 is a dodecagon. If we just want to use a generic term, we could call it an n-gon. How do we name a polygon? If we're referring to a polygon, we list the vertices, but in order. It doesn't matter which vertice we start with, whether it's A, or E, or D, or C, or B, but whichever vertice we choose, then we need to name them in order. Whether we go clockwise or counterclockwise, it doesn't matter. So this polygon could be named A, B, C, D, E, or E, D, C, B, A, or A, E, D, C, B. Does that make sense? Let's look at some terminology. What is a diagonal? Here's an image of what a diagonal looks like. It's a line segment that connects two non-consecutive vertices. Well, what is a consecutive vertice? A consecutive vertice means C and D, for example. They're right next to each other. If we connect C and D, we have a side. We don't have a diagonal. How about convex? Here's some examples of shapes that are convex. In a convex shape, you cannot draw a diagonal outside the polygon. Concave, on the other hand, if you'll notice these examples, the blue is a diagonal, and we could draw the diagonal outside of the polygon. For a shape to be concave, at least one diagonal can be drawn outside the polygon. What about equilateral and equiangular? They really mean the same thing, equal. Equilateral means equal sides. All sides have exactly the same length. Notice these red congruency marks. That's telling you that each side is congruent or equal to each of the other sides. And equiangular is all angles have the same measure. Notice these types of congruency marks telling you that all the angles have the exact same measure. What is a regular polygon? Examine these shapes. These are all regular polygons. What do all these shapes have in common? Well, if you said they all have equal sides and equal angles, you would be correct. A regular polygon has all sides the same length and all angles the same size. So in this triangle, for example, each one of these side lengths may be 3 centimeters, and each one of these angles has to be 60 degrees, as there's only 180 degrees in a triangle. If I examine this square, well, how many degrees are in a quadrilateral? a four-sided object? Well, we know there's 360. So if this is a regular polygon, it has equal lateral and equal angular parts. That means that each of these angles would have to be 90 degrees. Can you complete the phrase? If polygons are congruent, and remember, congruent means equal, then corresponding sides and angles are congruent. So what does that mean, corresponding? Corresponding means that the same side in one compared to that same side in the other has to be equal. And one angle in one of the objects that corresponds to that same angle in the other object must also be equal or congruent. Here, for example, we can use that rule. Which polygon is congruent to ABCDE? Here's ABCDE. Let's look through. Well, we know angle A is 100 degrees. We can also see some right congruent angles and some congruent sides. So if we look through here, this next one, we don't know what angle J is, so we don't know that it's congruent to this shape. This third one looks like a good choice. We have 100 degrees here and 100 degrees here. We know that these two angles match these two angles, and the bottom right angles also correspond here. This other shape here isn't even the same shape. So, if we want to know which polygon is congruent to ABCDE, it would be this one. But let's name it correctly. Since we started with A, what angle corresponds to A? Well, that would be Q. And then we go to B. B is 130, but how do we know that it's P or L? Well, think about how we named this. We went from A to B, so we went from A to B this way, so we need to follow in the same direction. So it would be Q to L, and then to M, N, and P. And that concludes our lesson today on polygons.